Lesson 8, Solving Rationals, Day 2. We actually have 3 days of solving rationals, just to kind of build you up to different levels. So there's going to be 4 examples today. Alright, so remember, first thing you want to do is check for LCD, least common denominator. Second thing you want to do this time is you want to look to see if you have factor, multiply, simplify, and then solve. Alright, so here we go. Let's change colors. So we have 4 examples this time. So example 1 is going to be 5 over y minus 2 plus 2 equals 17 over 6. Okay, now remember, the first thing you want to do is find your least common denominator. So we have y minus 2, this one's over 1, and this is 6. So we're going to do 6 times y minus 2. In some ways these are kind of easier, but they do get a little bit more, like there's a lot more going on. Alright, so 6 times y minus 2, 6 times y minus 2, and 6 times y minus 2. Make sure you're writing it over the top, and so we can cancel out just like we've been doing. Okay, so now these two cancel, leaving 6 times 5, which is 30. Nothing cancels here, so we just have 2 times, well, it's 2 times 6, which is 12, times y minus 2. And then the 6's cancel, and so you have 17 times y minus 2. Okay, so now we're going to clean it up a little bit. So we've got 30 still here, plus 12y minus 24 equals 17y minus 34. So we'll clean this up a little bit. So we have 30 and a negative 24, which we can combine to get 6. So we have 12y plus 6 equals 17y minus 34. Now, I like to keep my y's positive, or my variables, so I'm going to subtract 12y both sides to move it over here. This one will cancel out. And I'm going to move the 34 over here with the 6. This one will cancel out. So bring all that down, end it with 5y equals 40. Divide by 5, divide by 5, and y equals 8. Now remember, you want to check to make sure that it's not an extraneous solution or it's a no solution. So how you can check easily when you get these bigger ones is, instead of plugging it back into the whole thing, you can just make sure your denominators can't equal 0, otherwise it will be undefined. Alright, so 8 minus 2 is 6, and you can't plug it in here. So it does work. So check for extraneous or no solution. Okay, alright, example 2. Alright, so example 2. Okay, we have 7n over 3n plus 3 minus 5 over 4n minus 4 equals 3n over 2n plus 2. Okay, so we're going to do a couple things on this one. So remember, every example has a reason. Alright, so here we're going to go ahead and change this to negative and this to plus so we don't lose our sign right here. Alright, then we're also going to factor ahead of time. So on this one, we're looking at signs and factor first. Okay, oh, it's over there, you can't see it. There we go. Alright, so this becomes 3. Pull out a 3, you have n plus 1. Pull out a 4, n minus 1. And then pull out a 2, you have n plus 1. All right, so to find the least common denominator, we have a 3, a 4, and a 2, which all go into 3 times 4, which is 12. So we have 12. And then we have n plus 1s, and you only have to write it down once because it's only written once in both places. And then we have an n minus 1. All right, so this one's kind of long. All right, so we're going to write this least common denominator on top of each one of these. So you're going to have to keep it small and keep it neat. All right, so 12 n plus 1, n minus 1, 12 plus 1, n minus 1, and then 12 n plus 1, n minus 1. And you want to write it up there because that way when you're canceling out, you don't lose anything. All right, now also when you factor down here, you can mark through these so you don't get confused and you don't have too much going on. All right, so 3 goes into 12 4 times, and then the n plus 1s cancel out. So we have 4 times 7n. We can go ahead and multiply that together and get 28n. And then we also have the n minus 1, which is still there. All right, next one. 4 goes into 12 3 times. N minus 1 cancels out. So you have 3 times negative 5, which is negative 15. Okay, and you have the n plus 1 left. And on this one, 2 goes into 12 6 times. N plus 1s cancel out. So then you have 6 times 3. So 18n times n minus 1. All right, so all cleaned up there. All right, moving it up a little bit. Now we're going to do the distributive property. Okay, so we end up with 28n squared minus 28n minus 15n minus 15 and 18n squared minus 18n. All right, so let's combine some like terms here. We have some like terms, so this becomes 28n squared minus 43n minus 15 equals 18n squared minus 18n. All right, now we are going to set everything equal to 0 so that we can factor and find our solutions. So we need to bring all this over. So minus 18n squared and a plus positive 18n here. And minus 18n squared plus 18n. These will cancel out, leaving 0 over here. Bring down your negative 15. This becomes minus 25n, and this becomes 10n squared. All right, we have something in common here. 10, 25, and 15, you can factor out of 5, leaving 2n squared minus 5n minus 3. All right, so we're going to have to factor a little bit farther here. So we have 5 factor. So you have 2 times 3, which is a negative 6. And you need a 5 in the middle. So 6, 1, negative, positive. So n, 6, 1, negative, positive. Go divide by 2. And you end up with 5, 2n plus 1, and n minus 3 equals 0. Okay, kind of running out of space here. All right, so now if I solve this one, obviously 5 does not equal 0, so we're not worried about the 5. We have 2 options here. Okay, so we're going to have 2n plus 1 equals 0, or n minus 3 equals 0. So this one's going to give us 2n equals negative 1, and n equals negative 1/2, and this one is n equals 3. Now, and you don't have to plug in again to all this to try and figure out if these are going to work. So you can just check, and you can check the factored ones because that'll be even easier than plugging it back into here. So if you plug in a negative 1/2, it's going to be fine. It's not going to n equal 0 because you don't want n to be negative 1 or positive 1, and it's not. It's 3 and negative 1/2. So both of these options are true. All right, 2 examples down. There we go. so example 3, find the top of my page here. So example 3. So we have 2 over x plus 1, okay, minus 1 over x minus 1 equals negative 2 over x squared minus 1. Okay, so we got a couple things. We also have a sign here, so we're going to move the sign over here, make this positive, so we did a sign. And we can also factor this one. How convenient. It's a difference of squares, x plus 1, x minus 1. So factor. Alright, so our least common multiple is going to be x plus 1, x minus 1. I should probably write that in a different color. Alright, so we've got x plus 1, x minus 1 here. And again, get them up there, make it neat. Spread it out so you can see it. X plus 1, x minus 1. Alright, here, these are going to cancel. And then you're going to have 2 times x minus 1. This one is going to cancel, so you're going to have negative 1 times x plus 1, and then these cancel completely, leaving negative 2. Alright, so we're going to distribute this. So we're going to end up with 2x minus 2, negative x minus 1 equals negative 2. Clean it up a little bit, so we've got 2x minus an x, which is just x, and then the negative 2 and the negative 1 make negative 3. If you move the 3 to the other side, oops, you end up with x equals 1. Just getting ahead of myself. Now, we can't have x equaling 1 because we have 1 plus 1 is 2. That works, but this would be 0, and this one would also be 0. So this one is not a solution. So no solution because we don't have another one to choose from. So this rational equation has no solution. All right, we have one more example. We are almost there. Example 4. Okay, so we have 1 over p minus 2 equals 2p plus 1 over p squared plus 2p minus 8 plus 2 over p plus 4. Alright, so we have a little bit of factoring that we could do here. No sign changes on this one, but factoring. Again, this is why we did all that factoring for so long. Okay, so we have 4 and 2. 2 times 4 will be 8. One's going to be positive and one's going to be negative. So we need a positive 2 here, so 4 is going to be positive and 2 is going to be negative. That worked out nicely, right? So our least common denominator is p minus 2 times p plus 4. Alright, so we're going to multiply through by that. So we have p minus 2, p plus 4, p minus 2, p plus 4, and p minus 2, p plus 4. Alright, going back, this one cancels, leaving p plus 4 equals, these both cancel, leaving 2p plus 1. This one cancels, leaving 2 times p minus 2. Alright, we're going to clean it up a little bit. P plus 4 stays the same for right now. 2p plus 1 plus 2p minus 4. We have 4 p's here and here, and then a negative 3. P plus 4. Okay, we're going to subtract p from both sides and add 3 to both sides. These will cancel out, leaving 3p. These will cancel out, leaving 7 divided by 3, and p equals 7 over 3. Now, that's going to be fine right here, fine here. The only things we couldn't have is an answer of 2 or a negative 4. So, 7 over 3 works, so that is our only solution. And we're done. Now, you're going to have a paper assignment, or we're going to have an IXL for this one, and then our other assignment this week will have a Desmos activity, matching. So IXL, and you're going to be doing N7 to, let's just say 80. Okay, so IXL N7 to 80. All right, I will see you next time.